Okay, so hi everyone, I'm Suhail Khan, the Director of Development, Programming and Engineering for our customer-facing solutions at Huawei. My hope today is that you leave this talk with a better idea of how you can build a scalable IoT solution using an open source operating system. Yesterday, my colleagues Davide and Adrian gave an insightful introduction to HarmonyOS, and today I will be taking you through a technical deep dive. I come from this IoT and smart home industry, where I was building smart home solutions for one of the world's biggest utilities, along with partners who are pioneers in the IoT industry. So when I started building these solutions very early on, I realized it's different and quite complex to build them on a scale. So it came with a lot of new challenges to go from prototype to production as an OEM. I wanted to focus upon building new features for my end users rather than worrying about the underlying platform. I also wanted to swap out the underlying hardware seamlessly so that I can run my software configurations on different hardwares as the technology and product needs evolved over time. Plus, I didn't want to care about the long-term device maintenance. And on top of that, most importantly, I wanted all my devices to be secure. Because it is an essential requirement for smart devices, since these devices contain keys to our homes and to all our personal information. To meet these requirements, it was incredibly expensive. I had to go through many sleepless nights and complex development cycles with my programmers to achieve the end product that I was dreaming of. And all of this after a huge capital investment, and I knew my operational cost would be as high. And to top it all off, I wanted intelligent scenarios being developed on my product where the device would seamlessly collaborate with other devices in the environment. At this point, my only wish was that I stumble upon an open source operating system which would cater to all my needs and help me bring my product to the market while keeping the costs low. So here I am today, speaking to you about how I'm making my wish from a few years ago become a reality. Introducing to you HarmonyOS. HarmonyOS addresses exactly the pain points you as an OEM or an ODM or an IoT developer need to overcome, from being able to get your product quickly to the market through one-time multi-device deployment, or being able to build highly innovative solutions through an abundance of out-of-the-box software packages, or being able to keep your operational cloud costs in check by virtualizing interconnections between your devices. HarmonyOS offers you an open source fabric upon which you can build your next product. How do we enable these different functionalities? Through a flexible and secure distributed OS. This distributed layer approach enables you to convert your peripheral devices into virtual components, and the capabilities of these multiple virtual devices can be used synchronously. In the end, when you want to extend the capabilities from these individual devices, you form a super device which delivers an optimal user experience where the resources of each of your devices is utilized to their maximum capabilities. So here's a simple scenario to envisage this. Imagine a scenario where you are in a Zoom meeting, but instead of you sitting right in front of your laptop or holding your phone to your face, you want to have a complete hands-free experience where you're sitting on your couch while the content of your video is being streamed to your TV, and while your smart speaker's multi-microphone array is picking up the sound of your voice, and your indoor smart camera is streaming a wide-angle view of your environment. In this scenario, your smart speaker, your smart TV, and your camera are all working as super devices. And what's common between all of them? They are all running HarmonyOS as the underlying operating system. And all of this seamless inter-device communication is being done on your local network. HarmonyOS was born ready for IoT because it enhances your underlying hardware to its maximum extent. Here's an example of one of these supported reference boards, the HiSilicon 3516, which has next-gen image processor and latest H.265 video compression encoder, typically used for IP cameras and action cameras. And in this particular scenario, HarmonyOS enhances the networking layer through its distributed architecture. That way you have minimal anti-packet loss rate, in addition to cool features such as self-discovery and self-networking. And at the moment, we are supporting an ecosystem of 6 partners with 7 different chipsets based on the type of their end use case. It could be an IP camera, a smart home appliance, or even a smart home sensor or an actuator. Most of the innovative projects fail because companies or developers have their fingers in too many pies and lose focus on what's their core strength. For example, if you're an application developer, you wouldn't want to worry about the underlying hardware specification, or other way around. If you're an OEM or an ODM, you wouldn't want to worry about writing and maintaining the software running on top of your hardware. And our distributed architecture lets you focus on what's important to you. As a developer, you have hardware independence. You're free to pick the programming language of your choice, whether it be C++ or JavaScript or even Java. You get to build rich applications with fewer lines of codes, as there is modular decomposability per feature. As a manufacturer, you get to smarten your devices without increasing your hardware BOM costs. You shorten your time to market for new features because you do not have to develop them yourself. And you do not have to worry about the performance of your devices in different environments. As an OEM or a device manufacturer, you're always under pressure on reusability of the code across your landscape of the products, or about reusing the code across future generations of your products. Most importantly, you would want your products to deliver a uniform user experience and also a uniform performance across all of them. To encounter this, HarmonyOS provides application, ability, and UI frameworks, which allow you to reuse services and UI logic throughout the application development. This way, you can develop your application once and then deploy them across a broad range of devices, improving your development efficiency. So don't we all love beautiful architecture diagrams, especially when it comes with different layers of abstraction? HarmonyOS is designed with a layered architecture, which from bottom to top consists of the kernel layer, system services layer, framework layer, and the application layer. System functions are expanded by levels from system to subsystem and further to functions and modules. In multi-device deployment scenario, unnecessary subsystems or unnecessary functions or modules can be excluded from your system as you wish. Going layer by layer, here are important points to note, right? I could jump into each of them, but I guess we would have to expand the Eclipse Con to 5 more days. So I'm gonna hit the most critical points that we need to look at. So first we have the kernel subsystem at the bottom, and the kernel subsystem uses a multi-kernel design. It could be a Linux kernel, it could be HarmonyOS microkernel, or it could be LightOS. Then there is the HarmonyOS hardware driver foundation, which lays the essentials for Open Harmony hardware ecosystem. System service layer on top of it exposes different sets of distributed services to the framework layer. I will be diving deeper into the details of this layer in my following slides. Then the framework layer is where your business logic goes in with programming language of your choice, as I mentioned earlier. And application layer is what your end user sees as it consists of UI components and different templates. So starting with our distributed device virtualization. Earlier, I gave you an example about this. Recapping to a few minutes ago, this platform virtualizes devices and fully utilizes their advantages by assigning the most appropriate hardware to execute particular tasks. For example, device A would provide calling capabilities and device B would provide display capabilities. And together they form what we call a super device. Then there is the distributed data management. Distributed data management leverages distributed virtual bus to manage application data and user data distributed on different devices. Under such management, user data is no longer bound to a single physical device. You rather have a service logic which is separated from the data storage of your devices. In IoT, we always need to ensure that the right person uses the right data through the right device, right? So security is an important component of any IoT development cycle. So first, we have the hardware security modules. And the most critical blocks here are as follows, right? First, it is the boot root of trust. In the device boot process, the software signature verification is performed at each phase to form a secure boot chain. Then we have the hardware isolated trusted environment in which the chip isolation mechanism would ensure that you have a root of trust. And in HarmonyOS, the most common mechanism is the ARM trust zone. And finally, there is the hardware key engine, which allows you to perform computing tasks such as data encryption and decryption, certificate verifications, and also the hash value calculations. Now, moving on to the system level security services. Here too, we have different sets of services. Firstly, there is the process isolation, where the virtual addresses of two processes are mapped to physical address segments using the memory management unit. Then there is the discretionary access control, where there are three granularities of permission control. First, you have the user, then you have the group, and then you have your other sub-users. The file owner can classify any user into one of these three dimensions. And then we have the capability mechanism. Here the kernel spawns the first user program in it that has all the privileged mechanisms. And finally, something we've all touched upon as IoT developers, I'm sure, is the secure boot, which is the bare minimum. So usually after the bootloader is initialized, it verifies the integrity of the X509 certificate and verifies the image packages. Moving on, we have the data security as well. Here we focus upon giving access to the right data types. First, we have the universal key store service. And here you can export, import your different keys. Then there is the application signature management, where every application installed is successful only if it is authenticated. And finally, the application permission control. HarmonyOS allows users to install third-party applications and controls the calls made by these third-party applications towards sensitive data types. And usually these profiles need to be whitelisted in, for example, a JSON file. And finally, we look at how to secure the communication between your different devices. This is done through a public-private key pair exchange. There could be two kinds of devices. One could be your end user phone, and the other could be your IoT device. And each device has a unique identifier. So once the public keys are exchanged and the station-to-station authentication is done, every session is encrypted using a session key. So until now, we had a look at how HarmonyOS enables different features for you. Now we take a first look at how you can get started with building applications for HarmonyOS as a developer. To enable our community of open source developers with a shorter learning curve, we have developed bundles, or in other words, packages that you can start using as of today. We have the board level bundles focusing on the different hardware configurations. We have the system level bundles focusing on the different system level configurations, such as your kernel type. And then we have the application level bundles focusing on the end user vertical application, such as an IP camera or a smartwatch. And what are the best practices when it comes to building a bundle? Firstly, every bundle has to be independent. So in the end, you just compile one single bundle independently. Secondly, you need to make sure that your bundle includes all the services that you need to build your bare minimum product, which means you would also maybe at times need to include services from other bundles for the libraries that you might be missing. And third, if a group of bundles are implementing the same feature or functionality, then all of this can be combined into one single bundle. So let's start with building your first bundle. Firstly, as with anything in software development, you need to set your development environment. For this, you need the HPM package manager. You can find further details and instructions on how to set this up on our developer documentation. And once you have your environment set up, you initialize your bundle by running a simple command, which creates a tree structure with your bundle details. This structure has different folders, which contain, for example, your main class and also your header files. And in bundle.json is where you need to add descriptions and dependencies of your complete bundle package. You can either run an example bundle that we have, or you can go one step further and start modifying your bundle and play around with them. It's a lot of fun if you love IoT. I would say build, bundle, and enjoy. If you want to experiment with several bundles, then you have a distribution which contains the dependent bundles, and HarmonyOS allows inheritance from a distribution. In the end, a compiled distribution is a full system image. So what you saw until now was just a small preview of what's possible with HarmonyOS. And so I would say go explore all the different possibilities that we have with our open source project at the moment. You can reach out to us through email, and of course, visit our booth at EclipseCon. You can find further details about my talk on the booth as well. In conclusion, I would like to say that no open source project is really open source until the community drives it. Together we are stronger, so join my colleagues and I at the Open Harmony EU Incubator to overcome the industry issues we see in IoT. We want to make sure that either as a developer or a hardware vendor, you'll never walk alone. So thank you, and I guess it's time for some questions. Okay, so we have a first question here. Is it completely open source? Yes, even on the lowest layer, such as drivers. At the moment, the drivers that we are supporting, such as for Wi-Fi and Bluetooth, yes, they are open source at the moment. So second question, are you in touch with IoT and Edge working groups in Eclipse? Yes, we are. So my colleague Adrian is driving the collaboration efforts with the other working groups within Eclipse, and he would be happy to speak with you on this point. Okay. So I guess there are no further questions in the chat. I want to thank you all for your time, and it was my pleasure to speak at the EclipseCon. Thank you.